Hello my dear students, welcome back to NEET WORLD. So today in this session we will be discussing the basics of organic reactions. Okay, see, in the last sessions I have covered IUPAC nomenclature. What we have discussed in the last class? IUPAC nomenclature. So there are two sessions I have made on this IUPAC nomenclature. So if you haven't watched it, so just after this particular session you just go and watch it. Definitely you will feel more confident and more clarity on your IUPAC nomenclature for organic compounds. Okay, you can definitely answer question if it is present in your EAPCET this time. You will definitely write the answer for this IUPAC based question in the upcoming exams. Okay, that is for sure, because I have made it very clear with a clear cut explanation of all different like all models of IUPAC nomenclature. Okay, like different model questions we can expect now. So using previous year questions only, I have discussed the theory and the next I have explained the concept. Okay, now in this session see, once after completing IUPAC nomenclature, I can directly start isomerism right now. So I can start isomerism, or I can directly go through the electronic effects. Okay, so first of all let me explain you, first of all let me create some like a curiosity, or I can say the interest over organic reactions. Why do we need to make the reactions, and what are the minimum criteria we need to look for doing a chemical reactions. Okay, and see, there is very importance of these electronic effects in order to make chemical reactions. Okay, in order to do a chemical reactions. So let me show you some chemical reaction and the PYQs of these organic reactions, so that you will get clarity why do we require to study these electronic effects and how they play an important role during the like simplification or solving of these organic reaction mechanisms. Okay, so without knowing these electronic effects you can't solve the like reaction mechanism questions like SN1 reaction, SN2 reactions, elimination. All these reactions we cannot do without knowing these electronic effects. Okay, let me show you first some questions. Okay, let me first of all adjust everything is clear now, audio, video, right. Right, audio, video, everything is clear. Yeah, so here just look at these questions that are from previously asked papers. See these questions, see this is a very basic question. First of all, identifying electronic configuration you might be knowing, and identifying the names, IUPAC nomenclature of the given compound. So what could be the name of this compound, how can you name it? So if you are really troubling to answer these simple questions, I suggest definitely to you to watch my IUPAC nomenclature sessions that are discussed in the last day, I mean previous day, I mean yesterday and day before yesterday. So just watch these two sessions and make your IUPAC nomenclature better. Okay, alright. Next, look at this, let me show you. Look at this, what they are asking, decreasing order of stability of the given carbocations. How can you answer these questions, sir? See, these are carbocations mentioned, all of them are having positive charges here. So how can we understand which carbocation is more stable, which is less stable? Okay, so in order to understand this, see, generalized, tell me in a generalized way, we know chemical reactions takes place. Why the chemical reactions takes place? To attain stability right now. So during a chemical reaction the rearrangement of atoms or groups takes place to attain more stable state right now. So now these reactive intermediates, like I can say carbocations are reactive intermediates. So now this will be formed, see, look at here, see, I am not explaining complete reactive intermediates, I am just giving you some basic idea so that you will get more clarity why do we need to study the stability of carbocation, factors affecting them, stability of carbon anion, what are the factors affecting them. Just look at here. See, today we will be discussing like glimpse, like what is the importance of studying this reaction mechanism, electronic effects and all. Okay, just look at here. See, we know this is a methyl chloride, this is a methyl chloride now. So we know chloride is a chlorine atom is more electronegative, that will take the bonded electrons towards itself, as the electronegativity of chlorine is more than the carbon right now. So now what it will be generating on the carbon? See, if the bonded electrons are going with the chlorine, we will get CH3 plus, right now like this, and chloride ion will be the thing formed here. So now this is called what? This is called carbocation. What we can call? Carbocation. So this carbocation, see, initially when we are writing this starting material methyl chloride, how many bonds are there around the carbon? 4 bonds are there like this, right now 4 bonds are there. So each bond having 2 electrons, therefore how many electrons are there with this methyl carbon here? So it will be having now 8 electrons. So we know 8 electrons means octet configuration, that all the valency orbitals of carbon is fully filled, it will be more stable right now. But when this bond is breaking, so now the bonded electrons are going, these bonded electrons are going with the chloride atom only, chlorine atom only, becoming chloride. So now this carbon is now having how many electrons? Only 6 electrons are present right now. So if it is 6 electrons, see, it should contain 8 electron in order to gain its octet configuration, which is fully filled, that is stable right now. But now, as of now in the carbocations, how many electrons are there? 6 electrons are there. So just tell me, if there is only 6 electrons, will it be stable? No, right? It required 8 electrons, but it is having only 6 electrons. Therefore, carbocations are unstable. Okay, what I am saying? Carbocations are unstable. So during a chemical reaction, bond breaking and bond making takes place. When this bond breaking takes place, we will get something called intermediates like this. Carbocations, free radicals, carbon anions, intermediates are formed. Now, always remember, an intermediate is formed, it will be readily formed if it is more stable. What I am saying? The intermediate will be formed when it will be a more stable. Okay. So now look at here, I can form this methyl carbocation in this case. Here I have something like this. See, I am writing this 6-membered ring now. Same chlorine atom I am inserting any of these positions, like this I am writing a position. Okay. So now if I remove this chlorine atom from here, what happens? See, we will get a positive charge over here, like this we will get right now. Now if the chlorine atom is at here, then we will get carbocation like this. Okay. So these are the 2 different carbocations formed in this case. Hope you got some clarity, like when electronegative atom is removed, the heterolytic cleavage takes place, so that it will give a carbocation. These are the carbocations which are electron deficient, which are having only 6 electrons. Since they are having 6 electrons only, now the carbocations require 2 more electrons. That is what I can say, carbocations are electron deficient. If they are electron deficient, now if any adjacent groups are electron rich, then that rich groups will donate electrons to that electron deficient carbon. See, these carbon now require electrons. If there is any adjacent group which is more electron rich, that will donate electrons like this and make more stable carbocation, that will be stabilizes this carbocation. So this will be possible. When it will be possible? When there is any electron releasing groups, when there is any electron releasing adjacent to this carbocation. Now see, this carbocation is having one alkyl group from top side and one alkyl group from this side and one more from this side, and this one also having one over from this side and other one from this side. So here 2 alkyl groups, here 3 alkyl groups. So now what I wanted to say is, when there is alkyl groups are nothing but they are releasing groups. Why I am saying releasing groups? See here, a carbon is having positive charge and these adjacent carbons are having neutral. These are neutral I am saying. If these are neutral, now tell me, a positive charge carbon means same carbon, here also same carbon. A carbon with a positive charge means now it has tendency to gain the electron, like it is very hungry to take the electrons. Now if it is very hungry, now the bonded electrons are like strictly or more effectively dragging towards this positive charged carbon right now. So this effect is called inductive effect. Okay, this effect is called what? Inductive effect. I hope you got that. A carbocation is electron deficient. Now it requires electron that is given from the adjacent carbons. How that adjacent carbons is giving? See, these adjacent carbons give through this sigma bonds. If this is sigma bond, the sigma bonded electrons are taken towards polarizes more towards this positively charged carbon as it is electron deficient. So this effect is called, what I am saying, it is an inductive effect. Okay, remember it as inductive effect. And one more effect is there, that is called hyperconjugation. What is mean by hyperconjugation? To this carbon, adjacent carbons are called alpha carbons. Okay, so now whenever there is hydrogen atoms on this alpha carbon, we can say them as alpha hydrogens. So more the number of alpha hydrogens, more is the stability of this carbocation. So now look at here, how many alpha hydrogens are there? This side 3 and this side also 3. Therefore total 6 alpha hydrogens are there. If there is 6 alpha hydrogens, each alpha hydrogen stabilizes one time. So like that 6 times this carbocation is stabilized. So now how it will be stabilized? See, this carbocation is nothing but, here we have 6 electrons now, there is one vacant orbital. To that vacant orbital, out of this 3 hydrogen, each time one hydrogen will donates, I mean this alpha CH bond is there now, that bond will jumps into this vacant carbocation orbitals. Okay, like this. So that we will get a double bond here, and here it will be CH2, and H plus here remains like this for some time. Again this process will repeats with 2 more hydrogens every time, and this side also with this methyl group. Okay, therefore totally 6 times hyperconjugation is taking place. Like that it will be stabilized. Now look at the question, how many times, like which is more stabilized here? See, look at this question here. See, without having even much discussion, I am just giving you clarity on this question. Just tell me, with this discussion only, you just need to answer me this question. Now tell me, what kind of carbocations here we have? See, this carbon is just attached to one alkyl group right now, whereas this carbon, this carbocation attached to 3 other carbon atoms. It means this carbocation can be stabilized from above side, from these 2 sides also right now. So more number of electron releasing groups, more is the stability of the carbocation. So therefore B is more stable than A, we can say. Okay, and when it comes to BC, see, this carbocation stabilizes from this side as well as from this side, and this can also be stabilized from this side and from this side right now. Okay, now what I told you, after looking at the carbocations, we need to check for the adjacent carbons. See, on this adjacent carbon, how many alpha hydrogens are there? 2. Here how many are there? Only 1, remaining is methyl. On this you have 2 alpha hydrogens here and 2 more over here. So it means more the number of alpha hydrogens, more is the stability now. So 4 alpha hydrogens are there here, here only 3. So 4 is greater than 3 now. So therefore I can say D is more stable than C. Okay, first one is B is more stable, from here B is more stable, and after that between these two D is more stable, and after that C is more stable, and least stability is for A. So like that, where do we have an option here? BD, CA, BD, CA. So fourth option will be your answer for the question. Okay, how easy this is? Very easy now. Now with the same application, in the same manner, just I want an answer for this question. Just tell me, in the same way I want an answer for this particular question. See, I am writing here, this is a very basic, I know you can easily answer. Even it is wrong also, no issues, just give me your answer. This is very basic, everyone should answer me this in the chat box. Write your answer for this, A, B, C. Which is more stable out of these 3 compounds, tell me? Out of these 3 compounds. Yes, anyone here? See here, all of them are carbocations, but we know we know if adjacent groups are alkyl groups, then that will be more stabilized right now because it is electron deficient. So here 2 alkyl groups are there, here 3 are there. So where there is more number of alpha hydrogens or more number of adjacent alkyl groups, there it is more stable. So C, B, EA, that's it. This is how you can answer this first question. Now you got carbocation stability order. Now let's make a question here. See what is the question I am making, just look at here. To this we need to add one reagent called HBr here. Okay, we know HCl, HBr, HI, these are acids right now. So if this is an acid, what will be it is giving, like it is releasing H plus ion. So that this H plus ion now attacks on our this is a substrate. So where it will be attacking, tell me. So where it will attack, very simple, there is double bond now. So now this double bond will be taken like this H plus ion is taken by this double bond. See, I can add at this A place or this B place. So both possibilities are there now. So but we know after adding that H plus to this double bond, we will get a carbocation. See what type of carbocations we are getting here. Just see, if I add that H plus ion to this A carbon, we will get this kind of carbocation here. See if it is added here, see this pi bond is taken towards this side only and it is disconnecting here, so that you will get a positive charge here. Or if I add H plus on this side, carbocation will be on A side. So now tell me, based on the previous discussion, which carbocation will be more stable out of these two? This one or that one? Which carbocation is more stable? See, C or D, which carbocation is more stable? Just now we discussed, see this carbocation can only stabilized by two groups, these two groups. But this carbocation 1, 2 and this from top one. So 3 alkyl groups now, so that will be more stabilized. So it means the product formed from here will be major. So what will be the product formed here? Out of HBr, attacking of this H plus ion is over. Now what is the other thing we have here? Bromide ion. So where this bromide ion goes to the carbocation place, like positive, negative, and makes a bond like this, so that we will get Br, that's it. This will be a major product. What I am saying, this is our major product, and minor product comes from this. So what is a minor product here? Bromide ion will attacks on this and gives this one. So what I told you, which is major here? The one which comes from more stable carbocation. So what is our primary step here? Addition of H plus, addition of this electrophile H plus to our alkene. So it will takes place in such a way that the product formed or the intermediate, the next one species formed should be more stable intermediate should be formed. Out of this tertiary carbocation is more stable. See how important it is. It is very important to understand the stability of carbocation. Which carbocation is more stable? This tertiary now, that is why it is forming majorly, the product formed from that will be considered as major. Okay, hope the discussion is clear right now. Next one more question I am giving in the same way. I am expecting answer for this from your side. See here, I am expecting answer from you for this particular question. Here I am writing a double bond. See, I am not making you to feel too much hurry-burry here. It's very simple. Let's learn it very smoothly. See, even if you are starting from very scratch, you can easily understand this concept here. Okay? See, there is no hurry. Just feel free to discuss in the chat box and express your concerns. If you are unable to follow, just mention in the chat box. I will repeat it. Now tell me, what will be the product for this? What will be the major product formed here? Anyone can try this? Major product formed here. Where do we need to add this H plus and Br? See, I am giving here it as A position, this as B position. Where H goes, where Br minus goes? Tell me, what will be your answer for that? Yes, anyone? See, as per the above discussion, what I told you, there will be H plus ion here that comes out first, that will be taken by this double bond. Okay, so if I add at this A carbon, we'll get two possibilities. Right now, if I add at A carbon, we'll get H here and plus here, and if I add at this B carbon, then we'll get H here, positive charge here. Just identify which carbon is more, carbocation is more stable out of these two. See, it will be stabilized from 3 sides, this is only from 2 sides. So, which carbocation is more stable? This is tertiary. So, this will be more stable now, right now. Therefore, product formed from here will be major. Bromide ion will attacks at this carbocation now and gives Br. This is your major. Okay. Hope the discussion is clear, right? If this is clear, just click on the like button once, or you can express in the chat box, no issues. Right. Next I will show few more questions. Few more questions I will be showing you. Look at these, again related to same concept of carbocations. See what they are saying. Again, this question is very favorite question for all competitive like examiners. Whether it is JEE, NEET or EAPCET, this model question will be seen there. See what they are asking. Which one of the following will be most reactive for SN1 reaction? See, if you are a student who is preparing just for IPE, even if you are preparing for IPE, you could answer this question. How can you answer this? Because you will be studying this SN1 reaction as a part of your IPE exam, because SN1, SN2 reaction questions are definitely an important question for your IPE exam right now. So now tell me what you are studying there in SN1 reaction. It is a multi-step reaction. It involves carbocation intermediate. What is an intermediate formed? Carbocation intermediate. If there is a carbocation intermediate, then that carbocation forms all the time, which is more stable during the reaction right now. So now if you see, if you remove this, we will get a carbocation here. If I remove this chloride, we will get a carbocation here. Similarly, if I remove this chloride, we will get a carbocation here. Again, if I remove this, we will get a carbocation here. Now what they are asking, most reactive. Most reactive means if that carbocation formed is more stable, that will be most reactive. Now tell me, out of these 4, which carbocation is most stable here? See, till now we have discussed more the number of alkyl groups, that carbocation is more stable. See here, it is a 2 carbons are there, it is a secondary carbocation, only both 2 sides is there. Here we have from 3 sides, okay. So it means more than A, C is more reactive. C is more reactive than A. Let me give you final order. They are asking only one option. I will give you complete clarity on this question. See here, this side 1 carbon and this side 1 more carbon. It's a secondary now. And this one 1, 2, 3. Okay. So we have a carbon with 3 degree. Okay. It means 3 side alkyl groups are there, more stabilized. This one. Again, along with that, there is a pi bond here. If you observe, there is a pi bonds here in B and D. So that pi bond and this carbon, how they are? They are in this manner. See here, pi bond, and this is a double bond. So this pi bond will help in the stabilization of this carbon. How it will be helping? By shifting this pi electrons from here to here. That is what we can call it as conjugation. What is the name? Conjugation. So this conjugation is possible when a pi bond and a vacant orbital like carbocations are at alternate position. See, are they alternate or not? See, a pi bond, sigma bond and a positive charge. That is what alternate position. okay, or conjugative position we can say. Then it will be stabilized like this. So this pi bond comes here and this positive charge onto this carbon. See what is happening if there is no conjugation, positive charge is sitting only on one carbon. If there is a conjugation like this, a positive charge is spreading from here to here. It means if there is a weight on your head, if that weight is shared by your friends, you will feel relaxed right now. But here in this case there is no such conjugation, that whatever the weight on the head, it will be stays like that only, but here it is spreading through this number of carbons. So if it is like that, that will be get relaxed and more stabilized right now. So which is more stabilized here out of these two? Definitely here conjugation is there, means these two are more stable, but out of these two, this is a carbocation which is secondary, which is surrounded by 2 carbons only, but it is 1, 2, 3. So we know 3 degree carbocation with allylic, that will be more stable. So this kind of conjugation is called allylic conjugation, or system is called allylic system. Okay, so do not worry about the terms, try to learn them. Now I am using allylic. When I used, see, when pi bond and a carbocation are at alternate position, so what I am using the word allylic. What is that? Allylic. So try to write these names in your books. So allylic carbocations are more stabilized by this conjugation. So therefore this D will be more stable, after that B, and between AC, which is more stable, tell me? This is a secondary, this is a tertiary. So we can say tertiary is more stable, 3 sides it is covered, C, and this is A, that's it, that's it. So as per their question, most reactive one is D. And if I want to ask this in the next exam, I will be asking its order. So what will be the order? What will be the order? D, B, C, A will be the answer for this question. Okay, hope the discussion is clear. If the discussion is clear, just mention clear in the chat box. Yes. See, whenever there is carbocation, one thing you should get into your mind is that must be stabilized. In order to stabilize that, we require releasing groups. Releasing groups are nothing but like alkyl groups or any pi electrons in conjugative position. Okay, or lone pair electrons. Okay, right. Right. And next here, let me show few more questions. Yeah, we'll come to this type of questions once after knowing more and more content. See here, again look at this, it's looking very big structures are there. Do not scare by looking at the structures again. Okay, it's very easy to solve. What they have mentioned here, just see here, it is HI. What is this HI? It's a we know HCl. When I say HCl, we will say, sir, HCl is an acid. But when I say HCl and HI, which is stronger acid here? HI is very stronger acid than HCl. Okay, which is more stronger acid here? HI is more acidic than HCl. So it means if I take HI, so what it will readily do here? Releases H plus ion. If it is releasing H plus ion, that will be goes to the substrate side. So what is the reactive part in the substrate? That is what we need to look here. See, the oxygen of the substrate contain lone pair right now. So this lone pair will take this H plus ion. Okay, if it is taking that H plus ion, what happens? Tell me here. See, we will get something like this. We will get hydrogen here and a positive charge, because oxygen is given its electrons a positive charge. I am writing there. Okay. So now after this, tell me what happens here? Oxygen with positive charge. See, generally oxygen means it is a very electronegative atom, second most electronegative element in the periodic table right now. So now it is having a positive charge. Now what it will do? It will take the bonded electrons towards itself. Okay. See, if it is dragging this bond towards itself, now what is the charge creating on this carbon? We are going to get a positive charge here. Okay. If I do similarly on this side, if this is a carbon, it is dragging the bond, we are going to get a positive charge on this carbon. But we know which carbocation is more stable as per our discussion. This is tertiary carbocation is more stable. Na? So bond breakage takes place this side easily. So if it is breaking this side, so what will be the product formed here? it will be OH plus this side what we have, like this, and here we are generating a positive charge. So now this carbon is a tertiary carbocation, right now. So there we can add, out of H plus is added. What is the remaining part? I minus. So I minus will attach on this carbon. So finally, what is our product formed here? Like this. So this I minus it added, so iodide, it becomes alkyl iodide. That's it. So where do we have this kind of option? See, ethanol plus this kind of halide. So where do we have? So ethanol. In these two cases we have ethanol. So remove the remaining two options. Next, look at these two options. Yes, these are the two options we have. But what I shown you here, a carbocation is shown here. So carbocation is an intermediate. What I am saying? It's an intermediate. Where it is an intermediate? In substitution reaction. See, OH group of this, like alkoxy group of this substrate is replaced by iodide ion, right now. So one group is substituted by another group over here by what is the intermediate here? Carbocation. So whenever there is a carbocation intermediate involved, you should consider it as SN1 reaction. What is that? SN1 reaction. So where do we have SN1 here? So this is our option, and this is also one more product, and it is our SN1 reaction. So it is our SN1 reaction. So first option will be your answer for the question. Okay, right. Discussion is clear now? Yes. If this is clear, just tell me in the chat box. If not, again you just mention, I will explain it. No worries. Yeah. Next, let's see few more things here. Few more things I will be showing now. See, based on the previous discussion, now you can able to answer this easily. I know you will answer this. Just try once. The correct order of reactivity of hydrogen halides, how they will be reacting? Yes. See here, first thing here you need to mention here is propene. Correct order of reactivity of hydrogen halides. Take hydrogen halide. HX is our hydrogen halide. With what? With this propene. Propene plus HX. This is what they are mentioning right now. So these upon reaction gives some product. What is the product I told you? If this is HBr, I told you to add H here, Br here. So something like this will be your product. X here, and H here on this. So it means we need to know that the species that HX which gives H plus ion readily, that will involve in the reaction faster right now. So reactivity of propene will be more with that hydrogen halide which releases H plus ion readily. So who will release H plus ion readily? The stronger one. So down the group, if you see HCl, HBr, HI, if I write, what happens? See, halogens down the group, their size increases, but hydrogen size is smaller. So if the size is smaller hydrogen and halide ion is big, their bond will be very weak now. See, if the size difference is too much, means overlapping will be not good right now. If this is not good, bond breaks easily. If bond breaks easily, H plus ion comes easily. So it means that will more reactive. That's it now. So which halide ion, which HX is react here more easily? That will be HI. After that HBr, and after that HCl. So here if I write HF, so see, fluorine atom is small size, hydrogen atom is also small size. Therefore their bond will be very strong when you compare with the other things, because they are having, both of them are having similar sizes. If their size is almost similar, like 2s, like 2p of this f orbital and 1s of hydrogen orbital is overlapping to make this bond, which is a very stronger bond when we compare with others. So therefore down the group, the bond strength decreases, easily bond breaks, so H plus ion comes out easily. that will be more reactive. That's why we are saying HI as a stronger acid compared to the other acids. Okay, so HI, HBr, HCl and least is HF. So this will be your order of reactivity, order of acidic nature. So option C will be your answer for the question. See, all the things are very basic. First of all, no need to hurry or no need to be tensed about the complete chemistry, complete things to be learned here, the complete concept. No, just focus first on the basic parts first. What is the basic part here? What we have seen? First of all, why chemical reactions are taking place? Why chemical reactions are taking place? So, what are the reasons or factors? What are the factors affecting those reactions? See, why chemical reactions are taking place? To attain some stable products or some stability. Okay, so again chemical reaction, formation or deformation takes place to attain stability. So during this process there are some factors like temperature might affect. What are the things affect? Something like temperature might affect and pressure might be affecting sometimes, and sometimes the solvent in which the reaction is taking place might be affecting, and reaction can be faster in some special conditions, like any catalyst is used, so reaction will be speed of that reaction is be increased or decreased. So these are some factors to be understood here. Okay, so now for example here, what is the concept involved? Just their bond strength only, na? So who will give H plus ion easily, that will be more reactive. How can we understand that? Down the group the sizes of halide ions increases, down the group size of halide ion increases, but hydrogen ion size will be small. So due to that large size difference, the bottom wall breaks easily, the bottom HX, that bottom HI will easily breaks when I compare with the top HF, right now. Hope this is clear. And when it comes to alkene, what I told you, when it comes to alkene, reactivity of alkene towards this HX, okay, so what I told you, so bond will shift to accept this H plus in such a way to generate a more stable carbocation. So more stable carbocation, why it is? Because if it is forming more stable, that will be more stabilized. If it is more stabilized, reaction moves faster, that's it. So based on that we can understand which is major product, which is minor product, that's it. Very simple, do not scare by looking at the chemical reactions first. And one more thing I will show you, see here, I am writing C double bond O, R and some R dash, and here I am writing something like nucleophile, and one more term is called electrophile. Okay, so just see, do not just forget about what concept is involved here, just look at here. What I am saying is this carbon bonded to one oxygen, which is a double bonded oxygen here. And I have mentioned in one case nucleophile, another case electrophile. So with which reagent this reaction goes easily? So how can we identify this? See here, this carbon attached to an oxygen, double bonded oxygen, but we know oxygen is more electronegative than this carbon, right now. So the bonded electrons are shifts towards oxygen and make it here electron deficient on this carbon. What it will make? Electron deficient. Right now, if this is electron deficient, what happens? This carbon is looking for someone who can donate electrons, okay, who can donate or who can give electrons to this carbon, right now. So now I can say this carbon is now electron deficient. What is that? Electron deficient. If that is electron deficient, it requires a nucleophile. What do we mean by nucleophile? The species which allows nucleus. It means species which have more electrons, more electron density, is ready to give electrons to other species. That is what the nucleophile is. So here a negative sign indicates here it is having more electron density. So now it will be allowed to attack on the nucleophiles like positive electron deficient site. Therefore it will go and attacks at this site, that's it, okay, and we will get something like this R dash, C, R, that O becomes O minus, and a nucleophile is attacking here, that's it. This is what the thing is formed. So upon hydrolysis we will get R dash, COH, or Nu, like this. Okay, I will give one generalized, one good example of that, wait for some time. And here if you see, if I do the reaction with electrophile, see already this fellow is electron deficient, here it is becoming electron deficient, both of them are having electron deficiency, will the reaction happens here? No. So therefore electrophilic addition won't takes place here, only nucleophilic addition is taking place on the carbonyl groups, that's it. So this is what we can call it as nucleophilic addition reactions of carbonyl compounds. What is it? Nucleophilic addition reactions of carbonyl compounds. Hope the discussion is clear. Let me share you one example here. See here what I am writing. We have CH3 and C double bond O H, and this is reacting with CH3 minus. So what happens, tell me, CH3 minus means, so this is carbon is having a negative charge here. So carbon with negative charge is called carbon anions. See, more electron density now. So now what happens, we know this bond is taken towards oxygen, creating negative charge here and some partial positive charge on the carbon here. So negative charge will come, attacks over here and gives CH3, C double bond O minus, and CH3 here, new CH3 came here, this is new CH3 here. Okay, like this it is formed, followed by hydrolysis. If we do, it will become converted into alcohols. See, we have converted aldehydes to alcohols. What we made? Converted aldehydes to alcohol. Okay, so now here simply I mention CH3 minus. No, they won't give like CH3 minus, they mention it as some stable products, some stable reactants, reagents, like CH3 MgBr is a best example, MgBr. So this is called Grignard reagent. What is that? Grignard reagent. See, we know alkali metals, alkaline earth metals, alkali metals, what they will do? They will be electropositive. See here, magnesium alkaline earth metal will be +2. Our Grignard reagent means methyl carbon will be with negative charge, bromide ion with negative charge, right now. But here, sir, you are writing bromide ion negative charge, carbon with negative charge. Why you are attacking only CH3, why not Br minus? Might be this is one more doubt you will be having. See, carbon atom is less electronegative than this bromine, and carbon, due to its larger size, it can accommodate this negative charge in it. But this carbon, this bromine can accommodate this negative charge in it. But this carbon is smaller size, less electronegative than halides, and this negative charge cannot be accommodated in the small size carbon. So what it will do? It will always tends to donate that electron density to someone else. That's why the nucleophilic nature of these carbon negative, it means methyl carbon anion here is more when we compare with the halides. That's why methyl carbon anion is attacking over here to generate this kind of products. Hope the discussion is clear. Is this clear or not? Right. Right. Okay. Now tell me, based on this discussion, now tell me what will be the product formed here? Ethyl, C double bond O, CH3, and giving you here R, MgX. What is this R indicates? R indicates alkyl group, Mg indicates magnesium, and here X is an halide. So now it is taking place in some ether. Okay, this is first. Second step, H3O plus, acid hydrolysis. What will be the product formed here? So tell me what happens. See, this is a ketone. What is the functional group here? Ketone. You must know what are the functional groups. That's why I am suggesting you to watch the previous IUPAC nomenclature. There we have discussed about functional groups also. Okay. So now this R minus is a nucleophile, attacks here and gives ethyl carbon O minus, this is R, CH3, followed by hydrolysis means C, acidic hydrolysis, H plus is more there, that H plus ion comes here, that's it. So we got an alcohol product here. So from this what you have learned here, see if the product, if the reaction is taking place, with an aldehyde using Grignard reagent, aldehydes are giving secondary alcohols. See, this carbon attached with how many carbons? 2 carbon. OH group attached to a carbon which is having 2 carbon atoms to it. So you can say this as a secondary carbon. What is that? Secondary carbon. How can we identify secondary carbons? I mean secondary alcohol here. So secondary alcohols, just OH group attached carbon is there now. To that carbon, how many directly attached carbons are present? Directly attached 1, 2. So it is a secondary alcohol. Okay. So aldehydes upon treating with Grignard reagent gives a secondary alcohols. Remember this statement because they will make the statement based questions here. Okay. So secondary alcohols are formed from formaldehyde, like aldehyde, like acetaldehyde, and one acetone which is a ketone. They won't say ketone or aldehyde, they will mention names. Acetone is a ketone. So acetone means definitely it gives tertiary alcohol. See why tertiary? See it is a, acetone will be a ketone like this. All ketones upon treating with this Grignard reagent forms tertiary alcohol. See this is a tertiary alcohol. Why I am saying tertiary alcohol? See this carbon which is attached to the OH having directly attached carbons, directly attached 3 carbons are there, 3 sides carbons only. So it means you should say it as a 3-degree tertiary alcohol. Okay. I hope the discussion of the electrophilic centers and nucleophiles, how they will make the reaction is clear. Okay. So it means primarily what we need to do during a chemical reactions, you need to identify electrophile and nucleophile and make a chemical reaction between them. See always nucleophile will donate electrons to this electrophile and that will make a bond here. Okay, like this ENU type of product is formed. Okay, okay, is this clear or not? Okay, then next let me give you 1-2 questions and you can practice them. Practice them and try to answer me in the chat box. Okay. So from the next sessions we will be beginning very basic of this organic chemistry. Okay, very basic to make it more clear. Okay, that's it. So today I have shown you some different type of like different types of reactions so that we will get what happening here. See just what we did, all the reactions whatever we have seen till now, we have identified electron deficient center, whether it is electron deficient center or whether it is electron rich center. If it is electron deficient center, electron rich species will come and attack here. If it is electron rich center, electron deficient will come and attack here. That's it. Identify the site whether rich or deficient. Rich means deficient will attack, deficient means rich will attack. That's it. Okay. There is no reaction between deficient and rich. Okay. Always remember this. Okay. These terms only we are using here in the chemistry as nucleophiles. Electron rich means nucleophiles, electron deficient means electrophiles. That's it. That's it. This is a basic discussion. Okay. So now in order to make reactions you need to identify these 2 things. That's it. Okay. Now let me give you few reactions here and tell me what will be the product formed. See RCH2 Cl I am giving you and here I am treating this with OH minus. What happens, tell me, based on your understanding of this class discussion, whatever we discussed till now, from that discussion from the class, tell me. Yes, tell me anyone. See again chloride ion is more electronegative, comes out. If it is coming out, it generates a positive charge here, so there this OH minus will attacks. Okay, so that will generate as R CH2 CH2OH, that's it. This is our primary alcohol formed as a product here. So what we did here, we just seen what happening in the reaction. Say chlorine is going out, when it is going out as a chloride ion due to its electronegativity, it's going out as a chloride ion. Okay, so now it is generating a positive charge where electron deficiency is created. There this nucleus like electron rich species, we can say nucleophile, is attacking. Okay, now again remember if there is a reaction like this, OH minus ion is given, simply they will give OH minus or they may mention NaOH. Okay, now tell me what happens here. What happens here? Sir, till now we have discussed that carbon which is having double bond O, oxygen will drag the pi electrons, creates positive charge here. This is what we did the discussion previously. Right now, therefore, it means this negative charge will come and attack here, you might be thinking. But remember first, always remember during organic reactions, first of all, if there is a chance for acid-base reaction takes place. It means instead of attacking here first, OH minus will abstract an acidic proton. Where do we have acidic proton? See, carboxylic acids are acidic, therefore this H plus ion is taken and it will just forms a salt here, CH3COO minus, if it is NaOH, Na plus. This first this salt formation takes place, then only if any other reaction possible, then that reaction proceeds. But first of all remember, in a given organic reaction, if there is any chance for acid base reaction, first acid base reaction will be taking place instead of this nucleophilic attack or electrophilic reactions. Okay, remember this point, very very important. Okay, okay, then next. So now let me show you some questions. Okay, if you know the answer, just try to answer them. Just answer me this one. If you know them, you can easily answer. If not, I will be explaining them in the upcoming sessions. See, upcoming sessions means, first of all, let us cover the basics first. I mean, basics means tomorrow we will be discussing electronic effects like inductive effect, mesomeric effect, these things first, hyperconjugation, these things will be discussed, and using that we will solve the remaining GOC questions like stability of intermediates, reactive intermediates, and the product formation, possible product formations. Okay, all these things will be discussed in the upcoming classes. Okay, and that includes aromaticity and everything. And if you want answer for this, the questions which I have shown that are already solved in the previous discussion of top 30 organic questions, for EAPCET. Just search top 30 organic questions for EAPCET by Ajay Sir, or you just go to the playlist of this channel, it will be there in the live discussion sessions, okay, or in the recorded version. Just go and watch them that are recorded previously, so it is already uploaded. You just watch if you want to know the answers for these questions which I have projected here. Okay, so thanks for watching. So just stay connected and make your preparation more effective than any of the competitors. Okay, right. And any topic you are expecting from us, you just mention in the chat box, that will be covered in the upcoming sessions. Okay, right. Thank you for watching. Stay connected with us and you can share with your friends. Thank you.